Olá, bom dia a todos. Desculpa a demora. Estou aguardando com prazer estar lá pessoalmente hoje à tarde, mas agora vou contribuir só um pouquinho em inglês sobre pensamento de sistema. We did this once already, where I tried to do this in Portuguese and was judged. I had better redo it just to make sure that I was saying the things that I meant. So I'm just gonna share a screen. I'm gonna talk a little bit about tools in systems thinking and specifically causal modeling, which I think is familiar to some of you, but would be new for some others. And the reason to spend a bit of time now covering it as a group is to get to having a common way of thinking and a common language for talking about important connections in our systems. With causal loop modeling, we're trying to represent our system as a set of stocks, state variables, things that we can have more or less of, and connections among them. And where we're able to identify connections among things, that's a signal to us that they're part of a common system. And where we can't find meaningful ways that they're connected, then they're not part of the same system. And that's helpful for us to those models. Importantly, we're also looking for connections from some state variable through others, all the way back to where we started, to the same state variable. And when we find that, that tells us we have a loop. Feedback. Understanding how feedbacks behave can be really helpful for us to understand what we might expect from systems. So this is probably more helpful as a specific example. So I'm using a tool online called Kumi. Might already be a user, find it helpful to use. And I'm gonna ask us to pretend for just a few minutes that we're fishers. We're gonna think about fishing and fish stocks and our needs as a means to understand causal diagrams and feedbacks. I apologize. This is the quietest place I could find. All right. So imagining we're thinking about fishing and fish stocks, probably the first thing that's going to matter to us are fish in the sea. And if I'm thinking carefully about how it is that I get to have more fish, or how it is that fish make more fish without making it weird, is that fish reproduce. So I'm going to draw a causal connection, this gray arrow, from fish to reproduction. And I'm going to put a label on here, plus sign, blue color, meaning change in A, more of A leads us to more of B. It's change in the same direction. The more fish we have in the sea, probably the more reproduction we have. And similarly, the more reproduction we have, in theory, the more fish we get. Straightforward. Now, we've made our way back to where we started very quickly. We have a little feedback loop. And importantly, it's a particular kind of feedback. All of these connections go in the same direction. And this ends up being a positive or reinforcing feedback loop. Reinforcing feedback loops tend to take our system away from where it is, move it somewhere else. And in this case, where we have more fish leading to more reproduction, to more fish, to more reproduction, we're boosting our population. Similarly, we could have fewer fish leading to less reproduction, leading to fewer new fish, less reproduction. We could be declining in our population. Can't tell just by looking at it, but what we can know is that this kind of loop tends to move the system away from where it is. Now, on its own, imagining we had growth and reproduction, we'd have fish just fill up the universe. And we know that that doesn't happen. So there's at least one more thing we need to think about. And if I'm doing it carefully and simply, I might imagine that fish need to eat. And importantly, the more fish food we have available, the more probably energy fish have as surplus available for reproduction. I'm going to make this causal connection. And this time I'm going to indicate this as a negative loop or a negative causal connection. Sorry. This red arrow and the negative sign tells us more of A leads to less of B, or less of A leads to more of B. It's change in the opposite direction. Oops. I did that wrong. I jumped ahead. I actually want this to be positive. The more fish we have available, or so the more food we have available, the more reproduction we can have. It's this connection I want to be negative. So I wouldn't want it to say something like the more fish we have, probably the more they're eating, and then the less food will be available for us. We could make that explicit. We could break this apart into two pieces of more fish, more eating, or eating less food. But I think this works. Okay, so now I have my negative connection here, more fish, less food. And that gives me this other loop here. So more fish, less food, less reproduction, less new fish. This loop, we call a balancing feedback loop. So differently from a reinforcing loop or a positive loop, the balancing or negative loops tend to keep our system where it is. So these two loops are kind of working against each other. It's one loop that might be leading fish to grow in population, but then we have this limit of as our fish supply or as our food supply declines, we possibly have less new growth. Okay. We haven't talked about us yet. So imagine we are wanting to fish. One of the things that we would bring to the table is probably our effort in fishing. And I want to imagine that the amount of fish that we catch is some product of how many fish there are and how much effort we put into catching them. So let me suggest this. Let me suggest that the more effort we put into fishing, the more fish we catch. And probably the more fish in the sea, the more fish we catch. But then probably the one missing piece we want to put in here is that probably the more effort we put into capturing fish, the fewer fish are left. Now, this actually isn't a loop just yet. We have effort coming in, shaping how much we capture. There's nothing going into effort. This isn't a loop yet. But let's imagine, perhaps, that how much we capture influences how much effort we put in. And maybe it's the case that when we get lots of fish, we're excited about that. We go and fish more. Maybe we get lots of fish, we meet our needs and we don't need to come back. Depending on what we decide there, that could be a balancing loop, or it could be a reinforcing loop. Alternatively, what if we don't get a lot and we don't meet our needs, so we double our efforts and fish more? That's something that could be happening as well. So unless we know a little bit more about people and their behavior, it's tough to fill this in. We could imagine even perhaps representing these as separate processes. But what I wanted to show here is a simple model of fish growth, and fish harvest. This model doesn't tell us anything about where the system might be, how likely it might be to be stable. But what it does tell us is there's the possibility for some kind of feedback loop in the human behavior. And we have two clear feedback loops here when we look at how fish population responds. One of these is reinforcing and one of them is balancing. Any loop with an odd number of negative connections be a balancing feedback, just like in multiplication. Any multiplication with an odd number of negative numbers end up being a negative number. Where this can be helpful is for us to think conceptually about what matters in our model, talk to each other about the processes that we think can matter in our model. and as a starting point for computationally modeling our system, which is something we'll cover in the next session. So I'm going to stop here, and I believe Nick and Rodrigo are going to talk a bit more and run a few exercises so we get comfortable with causal modeling.